Our lesson today focuses on definite integral, which is a continuation of the Riemann sum. If you have not yet seen or watched that video yet, kindly find the link in the description. So, last lesson, we did say that a Riemann sum is what the summation from what k to n, k1, and that is the intervals, the function of what sk change in what x. And what did we say skx? Our sk it's equal to what a plus change in what x, a plus k change in x, and our change in x is what b minus a divided by what n. Okay, so in our definition of definite integral, we are saying that if f, let's say f is a continuous function defined on the interval, so defined on the interval a to b, and if this interval a to b is divided into n equal, don't forget we said they should have what equal width, so n equals sub intervals of width. Our width is what change in what x, and our change in x is what b minus a over what n. And if sk it's equal to what a plus k change in x is the endpoint of our sub-interval k, then we can define the definite integral of f from a to b. So then our definite integral of f from a to b, so the integral from f of x dx, so this integral is going to be the limit, from our previous lesson on limits, it's going to be the limit as x approaches infinity, the summation of what our area, which is what f of sk change in x. Don't forget it is from what k equal to 1 to what n, the sub intervals. So this is the definition of our definite integral. So the definition of our definite integral is this. Okay, this is the definition. So if you are given a definite integral and you want to use an integral, you're asked to use the definite integral to evaluate, then this is the formula we are looking at. And because we are talking about limits to evaluate our definite integral, then we need to know how to work with the sums. Okay, so it is very, very important to note the following equations, which gives the formulas for sums of powers of positive integers. So that if I have summation, let's say from k equal to 1 n of k, we are saying in some books you see I, so to there's 1, let's say 1, then let's say this is 1, this is n, into brackets n plus 1 divided by 2. Then another important thing to note is when it is to the power 2. So to the power 2, if I have my summation k from 1 to n, k squared is going to be n plus 1 to n plus 1 divided by 6. And if it is summation to the powers of 3, k cubed, that is k 1 to n, we are saying this is expressed as n plus 1 divided by 2 or squared. So it is very important to know the definition. So this is the definition for Riemann sum, and it is also very important to know how to use a limit to evaluate a definite integral. And in doing so, then you need to know how to work with sums. So these three are very important to note in looking at that. In our next video, we will take an example to evaluate using the definite integral. So then, stay safe and bye.